Okay, here we go. Video walkthrough of the exponential and logarithmic equations. I'm going to solve exponential equations. So as you saw in the introductory video, if you've got an exponential equation, the way to solve it is take the log of both sides. And generally we just use natural log because it's in the calculator and I can evaluate that. And the log rules apply. So if I take the natural log of both sides here, I get natural log of 8t is equal to natural log of -6, and hopefully right away you see a problem because we can't take the natural log of a negative number. So let's go back and look at this. If you think about it for half a second, how do you raise 8 to a power and get a negative number? Impossible. So this has no solution, which of course is possible. You can always have no solution. This is very similar to the one that we already did. So we'll just do it again, natural log. So that would be the natural log of e to the x is equal to natural log of 2e to the x minus 1. And if we use the log rules, of course, natural log of e to the x is just x. Natural log of that would be the same thing as natural log of 2 plus natural log of e to the x minus 1, which means x is equal to the natural log of 2, and that just is x minus 1. And move the x's over, so we have, when I subtract x from both sides, I get 0 is equal to natural log of 2 minus 1. That's a problem because natural log of 2 minus 1 is not equal to 0. So we have another solution. No solution, I mean. Oh, all these no solution? I hope not. Okay, here's another one. This one definitely has a solution. In fact, you could probably look at this one and see that it's got to be, x has to be 3 or 4, doesn't it? Because 3 to the 4th power is equal to 81. Or another way to look at that is, in this case, I could take I could take log base 3 of both sides because both of these things are a power of 3. Log base 3 of 3 to the x leaves just an x because log base 3 and 3 to the undo each other. And this is saying 3 to what power equals 81 and 3 to the 4th power equals 81. So that'd be 4. So the answer is x to the 4. Likewise here, these are both powers of 3, so you could take this, you could take log base 3 of both sides. Let's see, log base 3 of 9 to the x is equal to log base 3 of 3 to the x plus 3. Well, this one's, in this case, I'd probably put the x out front because then I can just take log base 3 of 9 because that's something I can do in my head. Same way here, kind of, except for log base 3 of 3 is, those just cancel each other out, so let's just be left with x plus 3. And log base 3 of 9 is 2 because 3 to the 2nd power equals 2. I mean 3 to the 2nd power equals 9. So this would just be 2x is equal to x plus 3. Subtract x from both sides and we get x is equal to 3. Yay, we're getting solutions now. Okay, here's one where we've got a 15 minus e to the, so if obviously I have an e to this, so I want to take the natural log of both sides. But before I do that, I want to get an e by itself, so I would subtract 15 from both sides, and that would give me -9 is equal to negative e to the x minus 8. And then I'd probably multiply both sides by -1. So now I have 9 is equal to e to the x minus 8. Now I'm ready to take the natural log of both sides. So that'd be natural log of 9 is equal to, and natural log of e to the x minus 8 is just x minus 8. So then my answer would be x is equal to, I had 8 on both sides, that'd be 8 plus natural log of 9, which is the perfect good answer, but if I wanted to round it off so it actually is a number, I could. If I grab my calculator, that would be natural log of 9 plus 8. So that would be approximately 10.197. Okay, number 8, let's see, we got a log on one side, that's log base 10 by the way, and 1/2 on the other side. Remember it's log base 10 if there's no, if they don't write any base and it's log, then you know it's log base 10. So how do I undo a log base 10? I make both sides a power of 10. So that means this would be 10 to the log of x plus 3. And this would be 10 to the 1/2 power. Of course, log, or 10 raised to the power of log base 10 cancel each other out, so this is just x plus 3, and this is the square root of 10, because 1/2 power means square root. Subtract 3 from both sides, and I get x is equal to the square root of 10 minus 3. And again, I can throw that in my calculator and get approximation, although this is a decent answer the way it is. So square root of 10 minus 3 equals approximately 0.162. Okay, here's another one where we've got a exponential on one side with a number and then a number on the other side. So first thing I'm going to do is get rid of that 29. So that'd be 10 to the t plus 12 is equal to, I'm subtracting 29 from both sides, so that'd be 45. And then I want to, man, that's an ugly t plus 12. I should have meant to write t plus 12. Okay, so then how do I undo 10 to the power? I take the log of both sides. So this is going to be log of 10 to the t plus 12 is equal to log of 45. Of course, those cancel each other out, so I'm left with just a t plus 12 is equal to log of 45, which means t is equal to log of 45 minus 12. And that is a good answer, but I can throw it in my calculator and get an approximation also, so I'll do that. Log of 45 minus 12. So we get approximately negative 10.347. Okay. Number 9, let's see this. So we got a log plus a log. That never is a good thing. So if we can combine them into one, that's good. Since they're both the same base, we can. So that's 1 equals log base 4 of, and then we'd multiply these. Okay, and then I have to undo a log base 4, so that means I make both sides of the equation a exponent of 4. So this would be 4 to the first, and this would be 4 to the log base 4 of 6 plus 2x. And of course that is just 4. But these cancel each other out, so I'm left with a 6 plus 2x. Subtract 6 from both sides, I get negative 2 is equal to 2x. And divide by 2, and I get negative 1 is equal to x. Check it to make sure it works. If I plug a negative 1 in there, I get 3 plus negative 1 is 2, and it's positive, so it's okay. I just can't have a negative inside the log, or a 0 inside the log. Okay, here's a natural log of both sides. How do you undo natural log? E to that. So you're going to do an e to the ln of x minus 1 and an e to the third power. And of course the e to the ln cancels out, so that's x minus 1 is equal to e to the third power. Add 1 to both sides and we get x equals e to the third power plus 1, which is approximately e to the third power plus 1, approximately 21.086. Here's another one where we have two logs added together. So we want to combine those if we can using the log rules. And so we know that natural log of xy is equal to natural log of x plus natural log of y. That's the rule we want to use. So this would be log of t plus 3 times t is equal to 1. And it's a log base 10, so I want to make both sides a power of 10. So that would be 10 to the log of, and that would just be t squared plus 3t, right? If I multiply that t through. And I have 10 to the first over here. the 10 to the and the log base 10 cancel each other out, so I'm left with a t squared plus 3t. And I got a 10 on the other side, so that would be t squared plus 3t minus 10 is equal to 0. And I think I can factor that, actually. Oh yeah. T and 5 and 2. Positive 5, negative 2. So that means t is equal to 2, or t is equal to negative 5. Got to check it to make sure. If I plug a negative 5 in there, I get log of negative 5, which can't be. So that's the extraneous solution. Kick it out. And that's my only answer. Very similar to the last one. We've got to combine them first. So that would be log base 2. And I'm going to go ahead and multiply that out. T times t is t squared. That would be t minus 2, which would be 0, and then minus 1. And that's equal to 5. How do I undo log base 2? I make both sides a power of 2. And so I got 2 to the log base 2 of t squared minus 1 is equal to 2 to the 5th power. And of course those cancel out, leaving t squared minus 1, and that t to the 5th power is 32. So that would mean that t squared is equal to 33. And t is equal to the square root of 33, or negative square root of 33. Negative square root of 33 is not going to work, because that would make that negative, so that's my only answer. T equals square root of 33. Okay, this one, you got log on both sides. That wouldn't be a problem, except for there's an extra 1 in there, so that is a problem. So I'm going to move this log over to the other side. So first of all, I have log base 3 of 4t plus log base 3 of 3t equal to 1. Of course, using the log rules, we can combine those, and that'd be log base 3 of 12t squared equal to 1. And then we want to undo log base 3, so we use 3 to the. So 3 to this power would leave me with just 12t squared, and 3 to the first power is just 3. So that means that t squared is equal to 3 over 12, which is 1/4. Take the square root of both sides, and I get t is equal to 1/2 or negative 1/2. And negative 1/2 is a problem. Positive 1/2 is not, so I cancel that one out, and that is my answer. Getting dangerously close to the end here. Now here's another log on both sides together, so I can combine those. Negative 2 is equal to log of 6. Oh, wait, they're subtracted. Whoa, that was a close one. That would be log of 2 divided by 3 plus x. That's how you do it when it's a log minus log. So I want to do log. This is log base 10, so I raise both sides to the power of 10. This would be 10 to the negative 2 is equal to, and that cancels out, so I got 2 over 3 plus x. Of course, 10 to the negative 2 is really 1 over 100. So that's 1 over 100 is equal to 2 over 3 plus x. And that's just a proportion, which means the means are the product of the means is equal to the product of the extremes, or some people call that cross multiplying. But that would be 3 plus x is equal to 200, which means x is equal to 197. That's big. Here's another one where we got a log on the wrong side. Looks very similar to that, doesn't it? So I move it over, and I get log base 2 of negative x plus log base 2 of 2 minus x is equal to 3. Combine them into one log. That would be log base 2, and negative x times 2 would be negative 2x, and negative x times negative x would be positive x squared. And that's equal to 3 still. How do I undo log base 2? 2 to the. So if I raise this to the power of 2, these guys cancel out. I'm left with negative 2x plus x squared. Raise this to a power of 2, that'd be 2 to the 3rd power, which is 8. So I have x squared minus 2x minus 8 is equal to 0. Can I factor that? Yes, I can. That'd be x and 2 and 4. And I want a minus 4 and a positive 2. Which means x is equal to negative 2 or x is equal to positive 4. And of course, negative 2 does work, because a negative 2 would be positive 2, and a 2 minus negative 2 would be 4. But I put a 4 in there, that wouldn't work. So that one doesn't work, and this one does. Sweet. This one's a similar one. This is ln of 4t minus ln of 3t. That would be ln of 4t divided by 3t using the log rules. And that's a problem because the t's are going to cancel out, isn't it? So that says the ln of 4/3 is equal to 2, which is not true. So this is no solution. Okay. I'll come back to 17 in a second because it's a unique one. This one, again, we're just going to combine things. So the log base 2 of t plus 1 over t minus 1 is equal to 3. Makes both sides a power of 2 to the power, so that'd be t plus 1 over t minus 1 is equal to t to the 3rd power, which would be 8. That would mean that t plus 1 is equal to 8t minus 8 if I just multiply both sides by t minus 1. And then subtract t from both sides and add 8 to both sides. So that'd be 9 is equal to 7t, which means 9/7 is equal to t. Will 9/7 work? Yes. Awesome. This one here, first thing I do is just divide by 3,000 because I want to get the e by itself. So 9,000 divided by 3,000 would be 3 equals e to the 2x plus 1. And then, of course, to undo e to that, we take ln, so that would be natural log of 3 is equal to the natural log of that, which would just be 2x plus 1. So then ln of 3 minus 1 is equal to 2x. So if I divide by 2, I get that. And you could throw it in the calculator if you wanted to, but you also could just leave it like that. Okay, and now this one up here, come back here. This is kind of a unique one because we got a bunch of e's together. I mean, we have a e to the 2 squared, e to the 2x, and e to the x. That's a little bit tricky because I can't really just take the natural log of both sides because they're all separated by minuses. So what I can do, though, is I notice it's kind of like a quadratic. So this is what is called u substitution. I'm going to make a little u substitution. I'm going to say, let's let u equal e to the x. And I mean by you, the letter U, not you, the people listening to this video. Haha, that was a joke. Okay, so if u is equal to e to the x, we know that u squared would be equal to e to the x squared, which can also be written as e to the 2x. So really, I could rewrite this with this u substitution as u squared minus u minus 6 equals 0. And of course, that is just a normal quadratic formula, or quadratic equation, which I can factor, I'm pretty sure. That would be u, and that's, what, 2 times 3 with a minus there and a plus there. So that means that u is equal, I said u, not 4. U is equal to negative 2, and u is equal to 3. But of course, u is e to the x. So what we really mean is e to the x is equal to negative 2, and e to the x is equal to 3. Of course, this is impossible. E to the x will never be equal to a negative number, but this is possible, and we can solve that by taking the natural log of both sides. So natural log of e to the x is just x, and natural log of 3 is natural log of 3. And of course, I can throw it in the calculator, get a decimal approximation, but that is also a good answer right there. So this doesn't produce an answer, this one does. So there's a pretty good smattering of exponential equations. Again, hopefully you had fun doing this.